Hello everyone. Today I'll be discussing about a tetrahedron program, that is the Sierpinski gasket. The logic of Sierpinski gasket is, as you have seen a wooden lamp on which a gasket was placed which was knitted. So this logic is hence the name it's been kept like gasket because of the output looks almost similar to it. Sierpinski gasket. Since this is with respect to 3D program, they have kept the name 3D Sierpinski gasket. Usually we consider a tetrahedron which has 4 faces, 1 face, so face 1, 2 and the background and the base face. So face 1, 2, base face is third face, the background face is fourth face. So we have 4 faces here. The logic of this is, consider one face. We take a midpoint of this and draw a triangle. This is with respect to first division. In the second division, we consider these small triangles and find the midpoint of this, and even for this small triangle and even for this small one. Then we draw a triangle for this. This is with respect to one face. When we take the other face, even for the other face, a midpoint is taken and a triangle is drawn. Again, with respect to smaller triangles, a midpoint is taken and a triangle is drawn. So this looks almost like a gasket, hence the name. Now we'll start beginning with how to take the coordinates of the Sierpinski gasket rather than by hearting the value of the coordinates. Consider a plane negative z, x-axis, y-axis and negative x-axis. I'll take, and this is positive z-axis. I'll take my first point here, that is 0, and my second point here. Third point is here. Fourth point is somewhere here. This is second, this is third. So if I join this now, so this will be one face, this will be second face, and the third face is 1, 2 and 0. I'll make a dotted line. This blue line is the line that is being joined. So we can see 3 faces here. 1, 0, 1, 3 is one face. 1, 2, 3 is one more face. 2, 0, 1 is one face, and 2, 0, 3 is the base face. If we take the coordinates of this, that is x, y and z, it will be minus 0.0, sorry, just 0.0, x, y is also 0.0, z is 1.0. So with respect to origin, it is 0 0 0 0. It has a point only on the z axis, so only z will be set to 1, whereas this actually x is 0 here. No, it's not, x is not 0, it is 0.2 minus 0.2, y is 0.9, z is, this is towards this side, so this is minus 0.3. If I take the values of this, x is minus 0.8, y is below, that is minus point around 4, and z is minus 0.3. If I take the value of this vertex, it is x is 0.8, y is 0.4, and z is minus 0.3. So this I have to place inside a variable called as b, which has 3 columns. So I'll place with respect to 0, that is 0 0.0, 0 0.0, 1.0, and this point of this minus 0.2, 0.9, minus 0.3, and the point of vertex 2, that is minus 0.8, minus 0.4, minus 0.3, and the point of this vertex, that is 0.8, 0.4, and minus 0.3. So this is done. The next is I have to divide the triangle now. So how many times I divided here? 2 times. Assume the number of times that I have to divide, let the variable be m. I'll take that as 2. So I'll call a function that divides my triangle. Divide triangle. So what should I pass? Initially I am taking one face of the triangle and I'll pass this A, B, C. So I'll be passing divide triangle A, B, C, and number of times that I have to divide is 2, that I'll be passing it here. So this is the first iteration. Fine. So what this function does is, this finds the midpoint. This finds midpoint between A and B, B and C, C and A, between all coordinates. So between A and B is with respect to all coordinates, means if I want to find a midpoint between A and B, A's x coordinate and B's x coordinate, A's y coordinate and B's y coordinate, A's z coordinate and B's z coordinate is considered. So A of x and B of x divided by 2. This is our equation, right, to get the midpoint. The same way, A of y plus B of y, sorry, AB is done, BC, BC, B into C, y, I'm really sorry, I am finding between A and B. So A's x coordinates is done. Now A's I have to take y coordinates, A of y plus B of y divided by 2. Again A's z coordinate and B's z coordinate divided by 2. How many times I am running here? 3 times. So I can take a for loop for, let me start with 0 and it should end when it reaches 2. So j equal to 0, 1 and 2, 3 times. That is for x, y and z. I'll increment the j. So a of j plus b of j divided by 2. This will be the logic. This is for line A and B. Now I have to do it for B and C. So I'll apply the same logic. For j equal to 0, j less than 3, j plus plus. So B of j plus C of j divided by 2. This is for line B and C. Now I have to do for A and C. For j equal to 0, j less than 3, j plus plus, a of j plus c of j divided by 2. This is for line A and C. Fine. So how it looks? It looks something like this. A, B, C. It has found a midpoint between these 3 lines. This happens when m is equal to 2. Now I'll decrement m by 1. Why? It has drawn a triangle, right? Fine. Now I'll decrement m by 1. Since my number of times that I have to divide is 2, I have divided only this one face. I have divided one face only for once. First time. I have to divide for second time since I have given number of times that I have to divide as 2. So in that case I have to call the divide triangle once again. Like divide triangle. What should I pass? Take this as V1, V2 and V3. So I have to pass A, V1, V3. A, V1, V3. This triangle. So I have to perform next only one iteration. Next I have to call divide triangle V1, B and V2. V1, B and V2. One more iteration. And V3, V2, C. Divide triangle. So I have to call V3, V2 and C. One more iteration. Correct. What happens when this is called? This calls this function again, when in which 2 will be replaced by 1. That's it. And it will call this for loop, where in which again this small triangle midpoint is calculated and a triangle is drawn. Again for this line it calls the divide triangle passing V1, B, V2. So it calculates the midpoint for all these 3 lines and draws a small triangle. Again we'll be calling V3, V2 and C using this line. So when the control goes here, it calculates the midpoint for all 3 lines, that is 1, 2 and 3, and it draws a triangle. Fine. So if this is the case, I can write the function divide triangle function something like this. Divide triangle, I'll be passing point A, point B and point C, and number of times that I have to iterate as an integer m. Since I need these variables, that is to take the midpoints, So of type point, I'll take v1, v2, v3, and I'll take the variable j, that is for loop, until unless if my m is greater than 0, what will I do? J equal to 0, j less than 3, j plus plus, yes. I'll calculate the midpoint of v1 of j. So I'm taking this, see, whatever the midpoint I have calculated here, that should be stored in one variable, v1, even this v2, even this v3, correct, v3 of j, v2 of j, means it will be all x midpoint of a and b will be stored in v of x, midpoint of one, yes, the other line, all a b c will be stored in again v1 of 0, v1 of 2 and v1 of 3 in the terms of x, y and z. So v1 of j equals a of j plus b of j divided by 2. For the other line, I'll take v2 of j. So it should be a of j plus c of j divided by 2. For j equal to 0, j less than 3, j plus plus, v3 of j equals b of j plus c of j divided by 2. Until where? Assume m was 2. So from 2 to 1. When it becomes 0, it comes out of the loop. In that case, I have to draw a triangle. If m was 2 and after decrementing by 1, so what will be the yield of this? I'll get a triangle midpoints of ABC, correct? Calling it as v1, v2, v3. A and B is v1. This is v1. A and C is v2. A and C is v2. B and C is v3. So this is v3. If it has not become 0, yes, I have to call the divide triangle again. What I have to pass? This chota triangle, that is v1, v3 and b, following by, what should I pass here? The same m, is it? Yes, tell me, m minus 1. I should be passing here m minus 1. The same, this is with respect to this. Now I'll call this. So I have to divide the triangle passing a, v1, v2 and m minus 1. And I have to call divide triangle v2, v3 and c. v2, v3 and c. Assume it has called this again and it has taken the midpoints. So in that case, my m will be 0. So what's the job? It has to draw a triangle, right? So once it has reached that 0, else I'll call draw triangle. We'll see the code of draw triangle. I'll pass A, B and C. Fine. This is with respect to divide triangle. Now, how many faces we have taken? Only one face so far. How many faces we have? 1, 2, backside 3, and the base 4 faces. So I need a function to call all those faces now. So I'll take one more function, void tetrahedron which takes M as an input. So for each and every phase, so what tetrahedron, so we have how many phase? 4 phase. So I have to call all these 4 phases now, right? Exactly. So this was V of 0. Sorry, this was V of 0. This was V of 1, as we have seen in this. So this was V of 0, V of 1, V of 2 and V of 3. The same I am taking V of 0, V of 1, V of 2 and V of 3. So with for each and every phase I am giving different color. GL color 3F. I'll assign red to one phase and I'll call divide triangle. So what should I pass? V of 0, V of 1 and V of 3, one phase with the value M. This is with respect to one phase. Now I have to assign one more color for the other phase. I will assign green color and I'll call the function divide triangle, which phase I'll take V of 1, V of 2, V of 1, V of 2 and V of 3, and I'll pass M as an input, and I'll set the color, different color for one more phase, blue color, and I'll call divide triangle V of 1, V of 2 and V of 0, and I'll pass M. So this is third phase. The last phase is the base one, so I'll assign black color for that, GL color 3F. So 0.0, 0.0, 0.0. While writing, make sure that C should be caps, even in the theory exams. So divide triangle, sorry I'm scribbling. So V of 2, V of 0 and V of 3. So this function calls each and every phase, that is all 4 phases, and for each one phase it calls a divide triangle function, which is here. So this calculates the midpoint. Fine. Now how does the who should call this tetrahedron function? They say that is nothing but display function. So before recalling, we have to clear the color buffer bit, GL depth buffer bit. Okay, since this is with respect to 3D. Next, load the identity matrix. Load the identity matrix. Then call the tetrahedron function, this, passing M, that is number of times it has to divide, and call GL flush, so it helps in fast rendering. So why draw a triangle? This is used to just draw a triangle when number of iterations become 0. So it takes point A, B, C. So inside GL begin and GL end, I need the each and every face to be filled with a color. So I am giving GL polygon, GL color 3F. Since A is an vector which is of 3 dimension and it has floating point, so I am giving GL vertex 3F V of A, GL vertex 3F V of B, GL vertex 3F V of C. Fine. And GL end. Now come to the main function. So here I am int main int argc cast argv. So printf enter the number of divisions it is asking. So I'm just scanning it and storing that in M. And glut. So what I am doing here, I am initializing the display mode to glut single, glut RGB means glut single buffer, glut RGB mode, and glut depth. I can take it here glut double. Since I am enabling the depth buffer algorithm, means I'll be enabling the depth test since I need which are the surfaces to be visible and which are the surfaces that will be hidden. So next I am initializing the window size to 500 means consider this is my monitor. If I say 500 I have not written one line here, but because it defaults take the value top left 00. So from here it is 500 width and 500 height. So this is 500, this is 500. It draws a window 500 and creates the window with the name 3D gasket. Means here I can see the title 3D gasket. So this will be our output window where you can see the output. So glut display reshape func of my reshape. As I explained in color cube program, reshape function make sure that the object shape is not distorted. At the end of this video I'll explain again if not. So glut display func of display means I'm calling the display function now. I'm registering it. Next GL enable, so which are the functions that I register it, so that will be called in an infinite loop by glut main loop. So next I'm enabling the depth test. Next I'm clearing color means I'm setting the background color to white. This can be written in int function, void int function, and even it can be called here int rather than this init. So I can write void init function and even I can add this line here. Next I am calling the glut main loop. So it calls whichever the registered functions that will be in loop, that will be called again and again. Fine. So coming to reshape function, what it does is, so the reshape function codes look something like this. For understanding purpose I have just written it. So void reshape, you won't be passing any parameters. It's left to the graphics compiler to pass it. So it will be width and height value. So first you have to initialize the viewport, which is from left and right value by default will be 00, and width and height. With this is viewport will be drawn. So viewport decides where your object has to drawn. Means consider here this is your monitor screen. It can be drawn here or it can be drawn even here. Assume this is your output. So this has been decided by viewport. So it decides where you have to display the output. And GL matrix mode you have to switch to the projection since we are dealing with views. And I'll load the identity matrix. If the width is less than or equal to height, means assume this is a square. If the height has become more on stretching the output screen, if the height has become more, then so GL ortho has a parameters left, right, bottom, top, near and far. Left, right, bottom, top, near and far. GL ortho. So the left and right value remains the same. The bottom and the top value is the one that has been distorted now. So that will be multiplied by the aspect ratio. Since height is more, h divided by w. So it gets to a form to the actual size if it has been distorted. So this is bottom and top value. This is near and far, minus 10 and 10. Else means if the object was something like this, means the left and the right portion of the object should be brought together closer. So in that case I get this object. In that case GL ortho, left and right is been multiplied by W by H, and bottom and top will be remains the same, even the near and far. Once this is done, we have to switch back to the model view. If not, whatever the changes we make further, it disturbs the object definition. So switch to GL matrix mode, GL model view, then glut post redisplay. See, I can call the display function. Why am I calling glut post redisplay is whichever might be the object that changes its shape or position something, if you display only those portions of an object, that's sufficient. Henceforth we'll be calling only glut post redisplay. Thanks for watching the video. For lab programs, yes, if you want you can drop me a message in the comment box. I'll be sharing the program. Thank you.